Bismillahirrahmanirrahim. Sallallahu alaihi wa alihi wasallam. Allahumma rabbi zidni ilma. Sallallahu alaihi wa alihi wasallam. Ameen. Alhamdulillahi rabbil alameen. The topic of this lecture is important questions of testing of hypothesis. For this lecture, I am using the work of an outstanding, a unique, the most dedicated and one of my best students, Miss Iman Anwar of class 2021, the Lyceum. An important advice for me and for everyone, we should be generous. Testing of the binomial distribution. Before attending a basketball course, a player found that 60% of his shots made a score. This 60% means P, the P of binomial, and this is H naught. After attending the course, the player claimed, now this is very important, he claimed that he had improved. Now this is the claim, and this is H1, and H1 has a greater sign because he said that he had improved. So we have greater sign here. So this means the P of binomial, and since he said that he had improved, so H1 involves a greater sign. Well, in his next game, he tried 12 shots. This 12 means the n of binomial. Make sure you read the question carefully so that you can easily extract the given information. And he scored 10 of them. This is the test value. Assuming shots to be independent, tests this claim at 10% significance level. Independent means this situation is of binomial, meaning this is x follows binomial with n 12 and p is of this value, h naught. The value of h naught is p. So 0.6 is here. And this is the alpha, the level of significance. And this test is of upper tail because of this greater sign. When H1 involves a greater sign, then we do upper tail test. The critical region is here. This is the probability of critical region, 10%. Now, we just need to check whether this test value lies here or here. If the test value lies in critical region, we will reject H naught and we will accept that the player had improved. If the test value lies here, we will accept H naught and we will reject the claim. So first work for the probability of test value. The test value is always inclusive. So since we are doing upper tail test, so we have to find this probability x greater equal to 10. So according to binomial, we have to take these numbers 10 or 11 or 12. This is the binomial formula. You all know binomial formula is nx px qn minus x. So by using this formula, you can get this probability. And this probability is 8.34%, which is less than 10%. This probability is less than 10%. Therefore, this test value lies in critical region. Hence, we have to reject H naught. That means we have to accept his claim that the player had improved. His claim is justified and he had improved. I hope you have understood this question. This question is of binomial distribution. Another example of binomial distribution. Isaac claims that 30% of cars in his town are red. Now this is the claim. Generally, claim is H1, but in this question, the claim is H naught. His friend Hardip thinks that the proportion is less than 30%, so we must have lesser sign here. This is the claim of Isaac, or you can say Isaac's claim. The boys decided to test Isaac's claim at the 5% significance level and found that 2 cars, this is the test value, out of a random sample of 18, this is n of binomial. Carry out the hypothesis and state your conclusion. So this is the binomial situation. With n 18 and p is 0.3. Well, this is the test value, this 2, this is the p of binomial, this is the level of significance, this is the sample size, 18. So we have to check this probability, whether this, and according to this sign, we have to perform the lower tail test. The critical region is here. This is the critical region, its probability is 5%. Now we have to find this probability in order to check whether this test value lies here or here. If the probability of this test value is less than 5%, then the test value will lie in critical region and we will reject H0. If this probability is greater than 5%, then the test value will not lie in critical region. Therefore, we will not reject H0. Now let's find the probability, this probability. So according to binomial formula, this is the probability of this number. It's 5.99%, which is approximately 6%. Since this probability is greater than 5%, which is the level of significance, so this number 2 does not lie in critical region. This number does not lie here, it lies here. Therefore, we have to accept H0. That means we have to accept Isaac's claim. Since 2 is not in critical region, so accept H0, that is accept Isaac's claim. This question is again of binomial. At the 2009 election, 1/3 of the voters in C voted for the Citizen Party. This 1/3 means P, the P of binomial. One year later, a researcher questioned 20 randomly voters. Now this is N. Exactly 3, this is the test value. Of these 20 voters said that if there were an election next week, they would vote for the Citizen Party. Test at the 2.5%. This is the level of significance. Whether there is an evidence of a decrease. Now this means the H1 involves a lesser sign in support for the Citizen Party in C since 2009 election. So this means lesser sign because of decrease. So lesser sign should be here. Now we have to perform the lower tail test. The lower tail test, we have to do the lower tail test. And the critical region is here. And this probability is 2.5%. Now we just need to check whether this test value lies in critical region or in acceptance region. Now this probability is greater than, this x lesser equal to 3 is greater than 5%, 2.5%. Therefore, this number 3 does not lie in critical region. The test value does not lie in critical region. It's here because this probability is greater than 2.5%. So we have to accept H naught. I mean, we have to reject the claim that P has decreased. So accept H naught and reject the claim. That is, reject the claim. That means P has not decreased. This means P has decreased. And this means P has not. You can say reject the claim, that is, P has not decreased. I hope you all have understood this question. Again, we have a binomial situation. Now, in this question, it is claimed that a certain six-sided die is biased so that it is more likely. More likely means the H1 has a greater sign. This means more likely to show a number 6 than if it was fair. So your probability of P is, the probability of number 6 is 1 upon 6 when the die is fair. So the H naught is P 1 upon 6 and H1 means P is greater than 1 upon 6, meaning this is fair die and this is unfair die. In order to test this claim at the 10%, that means the level of significance is 10, the die is thrown 10 times. This is the value of n of binomial. And the number of 6s is noted. So this distribution is binomial with n 10 and P is 1 upon 6. We always use the value of H naught here. Now the test value is 3. This is the test value and this is n, carry out the test. Now we have to just check whether this 3 lies in critical region or not. If this 3 will lie in critical region, we will reject H naught or vice versa. So we have to find this probability. Since this probability is 22.5%, which is greater than the 10% of level of significance, this is the level of significance, therefore this number does not lie in critical region. This number lies here. Therefore we have to accept H naught, meaning we have to say that the die is fair. 3 is not in CR, hence accept H naught, the claim is rejected, the die is not biased, the die is fair. See, the testing is very simple, especially by the testing of binomial. This is so simple. Again, we have a binomial question. Well, I'm not discussing the type 1 and type 2 errors, so I'm just discussing the testing. I will discuss type 1 and type 2 error in my next lecture, inshallah. Now, in this question, we have to first find null and alternative hypothesis. Okay, it is claimed that 30% of packets of fruit gum contain a free gift. This is P of binomial, H naught. Andrew thinks that the actual proportion is less than. Less than means the H1 involves a lesser sign. This means lesser sign. And decides to carry out a hypothesis test at the 5%. This means level of significance. And we have to perform the lower tail test. And the probability of critical region is 5%. He buys 20. This is the n of binomial. So you just need to write the distribution here if you want. So the distribution is of binomial with n 20 and p is 0.3. We always write this value of p here, the value of h naught. This value is always here. Now this is the test value 3. The first part is state the null and alternative hypothesis. Done. This is the answer of first part. We don't need to do this part. We are leaving part 2 because we are not discussing type 1 and type 2 error in this lecture. So we have to just do part 1 and part 3. Now part 3. Andrew finds that 3 means the test value, packets contains free gifts, carry out the test. So this is so simple. You just need to check the probability of this 3. Lesser equal to 3. Always use lesser equal sign whenever you perform the lower tail test. So this probability is 10.7%. So 10.7% means your 3 does not lie in critical region. I mean, this test value does not lie in critical region. Since 3 does not lie in critical region, therefore you have to accept h naught. You have to accept that you have to accept this claim, like the proportion is 30%. Accept h naught, that is reject Andrew's claim, or you should accept this claim. The fruit gums contains 30% of gifts. You can say here accept this claim, reject Andrew's claim, or accept the manufacturing company's claim. You can write your conclusion in any way. This one is fine. Question. Next question. Again, this question is of binomial. A die has six faces numbered 1 to 6. Manjit suspects that the die is biased so that it shows a 6 on a fewer throws. Fewer throws means the H1 has a lesser sign. This means a lesser sign, like this one. Then it would, if it were fair. So the probability of number 6 is 1 upon 6. So this should be less than 1 upon 6, H1. In order to test her suspicion, she throws the die a certain number of times and count the number of sixes. State suitable hypothesis. Done. This is the part 1. There are no sixes. No sixes means none. 0. That means q power n according to binomial formula. Show that this result is not significant at 5%. Not significant means this probability must be greater than 5%. Whenever it says not significant, that means the probability of test value must be greater than this percentage. This means not significant. Probability of the test value must be greater than 5%. And when it says it's significant, then the probability of test value must be less than this percentage. Because in the last part it says this result is significant. So the probability of test value must be less than this percentage. You must understand this concept well. So when it says not significant, so you just need to write this thing. We have to show, we just need to calculate this probability. When no sixes means q power n, we just need to check this probability. Since this probability is 6.49%, which is greater than 5%, therefore this result is not significant when this die is thrown 15 times. Shown. Now the next part, find the smallest value n if there are no sixes, meaning q power n, but this time result is significant. So this must be greater than 5%. Here you had to show this thing, qn greater than 5%, and this is greater than 5%. In the second part, here you had to show this probability must be greater than 5% when it says not significant. When it says it's significant, then you have to show this thing, q power n less than 5%, and q is 5 upon 6. You have to take log on both sides. Remember, whenever you divide this log here, you have to change this sign, because logs of probability are always negative. So the n is 17. We had to find n. This is very important. Whenever you divide log on this side, just change this sign. This was lesser sign, so when you will divide this here, this will become greater sign, because these two logs are negative. Next question. At a certain airport, 20% of people take longer than an hour to check in. Again, this is the binomial situation. P is 20%. A new computer system is installed and it is claimed. Now claim, this one is H1. This will reduce, that means lesser sign, to check in. It is decided to accept the claim from a random sample of 22. This is n. The number taking longer than an hour to check in is either 0 or 1. That means you will accept the claim if the numbers are 0 or 1. Meaning these numbers must lie in critical region. In order to accept the claim, these numbers must lie in critical region. So if you will find the probability of these two numbers, so this will be the probability of critical region. The first part, calculate the significance level of the test, that is alpha percent. This is the probability of the significance level, critical region. So critical region is 0 and 1. Therefore, this is alpha percent. Make sure you understand this concept well. It says you will reject H0 when the numbers are 0 and 1. Accept the claim means rejection of H0. So that means the critical region consists of 0 and 1. So you just need to find probability of 0 and 1 to get the critical region, probability of critical region. So this is critical region and this probability must be alpha percent. So when you will find this probability, you will get alpha. It is 4.8%. I'm leaving the next two parts. Now we have to do testing of the Poisson distribution. See, the number of accidents per month at a certain road junction has a Poisson distribution with mean 4.8. This is the value of lambda. This is lambda of Poisson. A new road sign is introduced warning drivers of the danger ahead, and in a subsequent month, 2 accidents. This is the test value, X. Number 1, a hypothesis test at the 10% level is used to determine whether there were fewer. Fewer means the H1 has a lesser sign. After the new road sign was introduced. Find the critical region for this test and carry out the test. You all know we find critical region in binomial and Poisson through trial and error method. So we will use trial and error method for the critical region. It's mentioned here that use trial and error method for critical region of binomial and Poisson. So we will use trial and error method. Now the test, you have to start trial and error method from the test value. Always start trial and error if the test value is given from the test value. The test value is 2. So first check this probability. X less than equal to 2. So X less than equal to 2 is 14.3%. So this probability is greater than the probability of critical region. Therefore, 2 is not in critical. So you just need to check the probability of less than 2, which is 1. So X less than equal to 1, the probability is 4.77%. That means 1 is in critical region. You have both the options. You can start the working from the test value, or you can start the working from the second value. 0 is in the critical region, so you can start your working from 1. So you have option. The best option is always start trial and error method from the test value. This is the best way. But this method is also fine. You can start with the second value. 0 is in critical region, so you start from 1. So if you will start from 1, you need to find this probability, x less than equal to 1. This probability. This probability is greater than, less than 5%. Since this probability is less than the probability of critical region, therefore 1 is in critical region. Now try number 2. The probability of 2 is 14 point less than equal to 2 is 14.3%, which is greater than 5%. Therefore 2 is not in critical region. So we have found critical region. The critical region is 0 and 1. This is the critical region. Now the last part of this question is carry out the test. Carry out the test means you have to check the test value, whether it lies here or here. Since the test value does not lie in critical region, so you have to accept H naught. It's mentioned here. Since the test value is 2 and it is not in critical region, so accept H naught, that means the claim is rejected. If you want to check the solution of this question again, you can. This is the formula of Poisson distribution. This is H naught, this is H1, and this is the lower tail test. You have two options, either start trial and error from critical value or start from 1. Here we started with 1 and we got this probability. So 1 is in critical region. And this probability is x less than equal to is 14.3. So 2 is not in critical region. And your test value is also 2. So you have to accept H naught and you have to reject this claim that lambda has not decreased. The claim is rejected. Next question is of Poisson. The number of sightings of a golden eagle at a certain location has a Poisson distribution with mean 2.5 per week. Now this is the lambda of Poisson. And this is per week. Make sure you understand the unit for Poisson well. Drilling for oil is started nearby. A naturalist wishes to test at the 5% significance. This is the alpha. Whether there are fewer means the H1 involves a lesser sign. This one. He notes that during the following 3 weeks, this means the test value, X. This means the unit of Poisson. 3 weeks means lambda. You have to change the value of lambda. Lambda is 2.5 and for 3 weeks it will be 7.5. It's here. And the test value is 2. This is the test value. Find the critical region for the test and carry out the test. Now you have option. You can directly start from the test value or you can start from 1. So it's better to start from the test value. So you just need to find this probability. Since the critical region is on left side or in lower tail, therefore find this probability less or equal to 2. Since this probability is less than 5%, that means your 2 is in critical region. Now you have to check number 3. So the probability of x less than equal to 3 is more than 5%. That means 3 is not in critical region. 3 is in the acceptance region. So the critical region will be 0, 1 and 2. This is the critical region. Now the question is carry out the test. The test value is 2. Now we just need to observe whether 2 lies in critical region or not. Since 2 lies in critical region, therefore accept the claim. Accept the claim means lambda has decreased. You are accepting this fact. When you accept the claim, you are accepting H1. That means lambda has decreased. Again, we have a Poisson distribution question. The number of injuries per month at a certain factory has a Poisson distribution. In the past, the mean was 2.1. This is the lambda of Poisson per month. New safety procedures are put in place and the management wishes to use the next 3 months. Now you have to change the value of lambda. It will be, I guess, 6.3. 2% significance whether there are now fewer. Fewer means H1 involves a lesser sign. Number one, find the critical region for the test. The first thing we have to find the critical region and then we have to perform the test. Okay, the first part is critical region. Now the test value is 3. You can start the calculation from 3, or if you want to, you can start calculation from 1. You have option. So this is the critical region. You have option. You can start from the test value or you can start from 1. It's your choice. The best thing is always start from the test value. That will make your calculation fast. Anyway, this is H0, lambda 6.3, and this is H1, and this is Poisson model, and we are starting from 1. So when we will take 1, we are getting this probability, and this probability is too small, is too short. This is less than 2%. That means 1 is in critical region. Now check the probability of 2. Now this probability is too large. So this probability is greater than 2%. That means 2 is not in critical region. The number 2 is not in critical region. 2 must be here in acceptance region. So the critical region will be 0 and 1. This is the critical region. Now, part 3, because we are not discussing type 1 error. Assume during the next 3 months, there are a total 3 injuries. This is the test value. Carry out the test. Since 2 is not in critical region, that means 3 must be in acceptance region. When 2 is not in critical region, then 3 must not be in critical region as well. So you just need to mention this thing. You just need to conclude this. You just need to write, since 3 is not in critical region, so H0 is accepted and the claim is rejected. When you accept H0, then you reject H1. That means lambda has not decreased. Testing of the normal distribution. This is the next topic. We have done binomial and Poisson. Now we have to do normal distribution. For this, you must be good at sampling. And you must have watched my first lecture on this topic, testing. Always watch the concepts lecture first and then questions lecture at the end. In summer, the growth rate of grass in a lawn has normal distribution with mean 3.2. Now this is very important. The distribution is normal and mean is 3.2 and standard deviation is 1.4. This means the case A of sampling, meaning your X follows normal with mean 3.2 and standard deviation 1.4. So for any sample size, the distribution of X bar must be normal. This is case A of sampling. Well, a new type of grass is introduced with the manufacturer claims has a slower growth rate. Now the claim is lesser sign in H1. A hypothesis test of this claim at 5% level was carried out using a random sample of 10. So this is 10 sample size that had the new grass. It may be assumed that the growth rate of a new grass has normal distribution with standard deviation 1.4. Find the rejection region for the test. This is so simple, you just need the critical region C. And this is the formula of finding the critical region in normal distribution. You just need to write Z test equals to Z critical. And 5%, this 5% means this 5%, this area. The critical region is at lower side. And this value is 2.47. When you check 5% from your calculator or table, you'll get this value is 1-1.645. When you will sketch the graph of Z, then you'll get this value. This is the 5% and this is the graph of Z, and this number is minus 1.645. This number is here. And this is the graph of X. Well, you need C. You need this number. This is C. So you just need to write Z test is equal to ZC. ZC is this. This means Z critical. So Z test is equal to Z critical when you reject H naught. So C minus mu sigma square over n. When you will solve this thing, you have mu, it's 3.2, and this entire thing is this. So when you will solve this equation, you will get the critical region, which is 2.47. And this critical region, and this value of test, this is the test value. This must be here. This must be in this region. So we must have lesser sign here. So when we perform lower tail test, we must have lesser sign when this value lies in critical region. Since this value lies in critical region, so this area, this means the value or the test value must be less than 2.47. The critical region is 2.47. In order to reject H naught, the test value must be less than C. Let me write this here. X bar must be less than C in order to reject H naught. So let me repeat this question. This information was given and it says a hypothesis test of this claim at 5% was carried out. Find the rejection region for the test. So whenever this says find the critical region or rejection region, you just need to equate these two. Z test is critical, get the value of C, this is the critical region, and this is the boundary of the critical region, this one. And in order to reject H naught, the test value must be less than critical region, the boundary of critical. So X bar must be 2.47, less than 2.47. When your test value lies here, you will reject H naught. And this region is critical region. So your test value must be less than C, which means test value must be less than 2.47. This is the second question of normal distribution. From previous years' observations, the lengths of salmon in a river were found to be normally distributed with mean 65. To test this theory, a researcher suspects that the pollution in water is restricting. Restricting means lesser sign. Mu has lesser sign. H1 has lesser sign, in fact. To test this theory, she measures the length x and she got these results. This is sigma cap square, unbiased estimate of population variance. This means sigma cap square. It's mentioned. So sigma cap square is 4.9. She then carries out an appropriate hypothesis. Her test statistic is this. This is the z-test. Calculate the value of n. So this is so simple, you just need to equate z-test with z-critical. This is z-critical, 5% minus 1.645. Z-test is equal to z-critical, and z-test, this is the test value 64.3. It's here. Sample mean, this is the test value in normal distribution. Sample means the test value. This is 65, it's here. And 4.9 square upon n is here. When you will solve this equation, you will get the value of n. Using this test statistic, carry out the hypothesis at 5% and state what her conclusion should be. So this is so simple. See, z-test is minus 1.807. This is given. Z-test is given. It's here. Let me explain the first part again. This is z-test. So when you will use the formula of z-test, this is the formula of z-test. Z-test has this formula, x bar minus mu sigma over ns. This is the formula of z-test. So z-test is minus 1.807. So by using the formula of z-test here, we can get the value of n. Now, this is the critical region, minus 1.645. Since this z-test lies in critical region, minus 1.807 lies here. So you have to reject H0. You have to accept this claim that mu has decreased. Reject H0, evidence that there is a significant decrease in length. Or you can say mu has decreased. That is, mu has decreased. You are accepting this fact because your z-test lies in critical region. Again, we have a normal distribution question. The lectures in mathematics department are scheduled to last 54 minutes. This is mu, H0. And the times of individual lectures may be assumed to have a normal distribution with mean mu, standard deviation 3.1. This is the case here of sampling. This mu is here. One of the students commented that on average the lectures seem too short. To investigate this, the times for a random sample of 10. This is the sample size. Lectures were used to test the null hypothesis 54 against this alternative hypothesis at 10%. Show that the null hypothesis is rejected in favor of the alternative hypothesis when x bar is less than 52.74. See, this is the test value. When this test value is less than 52.74, you have to reject H0. So basically you have to show this thing. Well, when do you reject H0? That's the important question. You reject H0 when your z-test lies here. So we reject H0 when z-test is less than z-critical. When z-test lies in critical region, then we reject H0. And it says the H0 is rejected. So make sure you learn this thing and you understand this thing well. We reject H0 when z-test is less than zc. That means z-test is lying here. So by using this inequality, we can show this thing. So z-test x bar minus 54 upon this thing, 3.1 square upon under root 10. Let me write the formula for x bar. X bar is normal with mean 54 and standard deviation, variance 3.1 square over 10. So you just need to write under root of this here. And we have shown this. We are not interested in type 2 error in this lecture. This thing is very important. We reject H naught when Z test lies in critical region. With the help of this thing, you can easily show the answer. Show this requirement. Well, in this question, number one, we have to do the testing, and then type 1, type 2, we will leave this part. A study of a large sample of books by a particular author shows that the number of words per sentence can be modeled by a normal distribution with mean this and standard deviation. This is the case A of sampling. A researcher claims, now this is the claim, to have discovered a previously unknown book by this author. The mean length of 90, this is N, sample size, is 19.4. This is the test value. This is NS and this is X bar. And this is the mu of normal distribution, and this is the sigma of normal distribution. So the distribution of X bar follows normal, and mu is this, and the question is, assuming the population standard deviation is unchanged, 7.3, yeah, it's given unchanged, test at the 5% whether the mean sentence length is the same. Now this means the two-tail test. This same means same and not same, means same and change. So mu H1 has this sign, not equal sign. You are looking for a change in H1. So this is a two-tail test. So this 5.5% will be divided into two parts, 2.5% here and 2.5% here. And you can get this value from your table or calculator, 1.96. This total is 97.5%. So this number is 1.96. Therefore, this must be minus 1.96. State your null and alternative hypothesis and perform the test. So this is the null hypothesis, this is the alternative hypothesis, this is the test value. We just need to calculate Z test first. This is the formula of Z test with respect to this distribution. The value of Z test is minus 2.3392, and this value lies in critical region. Since this value is less than minus 1.96, therefore this number lies in critical region, so reject H naught, meaning you have to accept that mu has changed, accept the claim. We won't do this part. Next question, 13. The time taken for Samuel to drive home from work is distributed with mean 46. Now distribution is unknown. We are not sure whether this is normal or not normal. Samuel discovers a different route and decides to test at 5%. This means mu of the distribution, and this is alpha, has changed. H naught has this sign, not equal sign, because of this change word. He tries this route on a large number of different days. Null and alternative. Mu has not changed, mu has changed. And Samuel calculates the value of his test statistics. This is a Z test, minus 1.729. What conclusion can he draw? Well, this 5% will be divided equally into two parts, 2.5, 2.5. This value is 1.96, this is 1.96, negative. This is negative 1.96. Well, you just need to observe this test value. This test value this does not lie in critical region. This value is here. Since Z test is greater than minus 1.96, therefore you have to accept H naught. That means mu has not changed. This value minus 1.729 is greater than minus 1.96, therefore you have to accept H naught. A machine has, this is the next question, question 15. This is of normal distribution question. Change. Again, we have a change situation. So H1 has not equal sign. To test this belief, a random sample of 8. So this 8 is here. And this is the test value 21.7. 5% significance level, mean has changed. This question is very simple. You just need to calculate z test. Z test is minus 1.947 and you are doing this at 5%. For your conceptual clarity, I am making this sketch. 1.96. This student is very smart. In fact, one of my best students. So she normally does directly. She does the question directly. But students, average students like me, should not do questions directly. Since this number minus 1.947 does not lie in critical region, it lies here. Therefore, you have to accept H naught. Minus 1.947 is here. It is in acceptance region. So accept H naught and reject the claim that mu has not changed. You can say, if you want, you can say that is mu has not changed. This is the next question, number 18. People who diet can expect to lose an average of 3 kg in a month. This is mu of normal distribution. This is the measurable quantity. In a book, the authors claim that, this is the claim, people who follow a new diet plan will lose an average of more than 3 kg. So H1 involves a greater sign. In this case, we have to perform the upper tail test. The weight loses of the 180, this is sample size. The mean is 3.3. This is test value. This is the test value, x bar. Standard deviation is 2.8. The test the authors claim at 5% and state your null and alternative hypothesis. Null hypothesis mu is 3 kg. Mu has not increased. This means mu has increased. N is 180. Test value is 3.3. Standard deviation is 2.8. You can easily perform according to CLT. Since for large samples, we use CLT. The distribution of x bar is normal. This is the way to guess the z test. Z test is 1.437 and the critical value of z is 1.645. So this value does not lie in critical region, this lies here. Since this value lies in acceptance region, so we have to accept H naught. That means we have to reject this claim that mu has not increased. When the test value lies in acceptance region, we accept H naught. When the test value lies in rejection region, we reject H naught. This is so simple. The times taken for the pupils in Ming's year group to do their English homework have a normal distribution with standard deviation is given. Our teacher estimates that mean time is 42. This is here. Sample of 3. So x bar is normal. Okay, this is case of sampling. And with the help of these 3 data values, we can get the test value. This is the test value. This is the size sample 3. Sample of size 3. This is for the test value. And this 3 is here. Carry out the hypothesis test, 10% estimate for the mean should be accepted. Teacher says, let me check this. Mean time is 42. And the mean from this is 35. So same and change. So this is your mu 42 and this is change 40, not 42. So first you need to calculate z test with the help of this data. and this 35. Z test is this, and the critical region is at 5% on both sides. So this value does not lie in critical region, it lies here. So you have to accept H naught. That means mu is same, or mu has not changed. Question 22. In Europe, the diameters of women's rings have mean 18.5 millimeter. This is mu. Researchers claim that women in Jakarta have smaller fingers, so lesser sign must be here than in Europe. The researchers took a random sample of 20. This must be 20. And women in Jakarta and measured the diameter of their rings. The mean diameter was found to be 18.1. This is the test value. And standard deviation is 1.1, and this is 2.5%. The test critical region. This is the level of significance, in fact. This is for your conceptual clarity. This is minus 1.96. Since this number does not lie in critical region, it's not lying here, it lies in acceptance region, so accept H naught, that mu has not decreased. The claim is not justified. When you accept H naught, basically you are accepting this fact that mu has not changed, mu has not decreased. Question 83. In the past, the time spent by customers in a certain shop had been 12.5. This is mu. Standard deviation 4.2. Following a change of layout in the shop, the mean time spent in the shop by a random sample of 50. So this, because of this large sample size, the distribution of X bar is normal. And this is the test value 13.5. Assuming that the standard deviation remains 4.2 minutes, test at the 5% significance level whether the mean time spent by customers in the shop has changed. So two-tailed test. 5% meaning 1.96 at both sides. This is plus, this is minus. And this is 13.5 test value, 12.5 here, and the square root of this here. Since this number does not lie in critical region, this is lying here, so accept H naught and states that mu has not changed. Mu has not changed. Question 85. In the past, the mean annual crop yield from a particular field has been 88.2 tons. This is mu, because measurable quantity means mu. During the last 16 years, this is N. The mean yield for these is 8.7. This is the test value. Assume that yields are normally distributed, standard deviation 1.2. So you have to use this formula. Carry out the test at 5% significance has increased. So H1 has a greater sign. So this is 1.645 and your Z test is 1.67. This lies in critical region, so you have to reject H naught. You have to accept that mu has increased. Reject H naught, mu has increased, accept the claim. In the past, the time in minutes taken for a particular rail journey has been found to have mean 20.5. This is mu. Standard deviation is 1.2. Some new railway signals are installed in order to test whether the mean time has decreased. So mu H1 has a lesser sign. You can say that mu has decreased. And here you can say mu has not decreased. You should assume that the standard deviation is unchanged. Make sure you remember this thing. Whenever this asks, state the assumption you use in the calculation. So you have to mention this. We assume that standard deviation is unchanged. Carry out a significant test at the 4% level whether the population mean time has decreased. This is the test value. So z test value, mu, and standard deviation, and this is ns. For your conceptual clarity, I'm writing this thing here: 20.5, 1.2 ki square over 100, and we use this thing here and here. Critical is minus 1.751 and z-test is minus 1.667. This does not lie in critical region, it lies in accepted region. So we have to accept H naught, we have to accept that mu has not decreased. Question 38. A clinic monitors the amount X milligrams per liter of a certain chemical in the blood stream of patients. For patients who are taking drug A, it has been found that the mean value is 0.336. This is the mu of normal distribution. When we will use CLT, the mu of X bar, in fact. 100 for large samples, the distribution is of X bar is normal, approximately normal. We have this data for the unbiased estimates. First get X bar, and X bar, you can easily get X bar by using this formula. Sigma X over N, this is the test value. Sigma cap square, you know the formula, N upon N minus 1, sigma X square over N, and mean. This is the value of sigma cap square. Test at 1% significance level whether the mean amount is different. Different means not equal sign. Different means like change. So H naught is this and H1 has not equal sign. So this is the Z test. We have X bar, it's here, and the Z test is 2.767, whereas Z critical is 2.576. For your conceptual clarity, I'm making this sketch because you understand the things well from sketch. This is the Z critical. This is the critical region. You just need to compare your test value with this value. Your test value is greater than this value. This means this lies in critical region. So you need to reject H naught. You have to accept that mu has changed. Well, this is the next topic, normal approximation to binomial distribution. This student has done a lot of hard work. This shows her caliber. I mean, you can judge the student from her work. She has done a lot of hard work to make this PDF. Indeed, she is an outstanding and a unique student. In fact, she is one of my best students. Now the topic is normal approximation to binomial distribution. So we will solve, we did this thing in S1. Here we have to do continuity correction as well. Each multiple, when do we do normal approximation? I discussed this thing in my first lecture of testing. Basically, we do normal approximation to binomial distribution when n is greater or equal to 30. This is the hint. And when NP, and this is the condition. This is the condition for normal approximation. But listen, when n is greater or equal to 30, then both the methods of calculating the probability through binomial distribution are lengthy. So we use normal approximation and we do continuity correction. We use number line for that. Each multiple choice question in a test has 4 suggested answers exactly. One of which is correct. So each question has 4 answers and 1 is correct. That means the probability for correct answer is 1 upon 4. For example, if A, B, C, D are the options, then one answer will be correct. So probability of correct answer will be 1 upon 4. So H naught is P 1 upon 4. Miss Rekha knows nothing about the subject of the test, but she claims that she has a special method for answering the question that is just better than guessing. That is better than just guessing. That means H1 has a greater sign, because this is her claim. 60 means n. This is n means sample size. The n of binomial, in fact. This is the n of binomial. It's here, and this 1 upon 4 is here. And this is the test value. Null and alternative hypothesis done. Part 1 is over. Now, using normal approximation at 5%, whether her claim is justified or not. See, for normal approximation, you use NP and NPQ. This is NP and this is NPQ. This is binomial and this is normal approximation. And this is the test value. But here you have to use number line. Make sure you use number line for continuity correction. 22. And the test value is always inclusive. The test value is always inclusive. So this is of binomial distribution and this is the normal approximation. Take the lower bound. Whenever you go on right side, we always take the lower bound. So 21.5 is here. And this is NP and this is NPQ. You don't need to calculate this probability, you just need to calculate z-test. I solve all questions of this chapter through z-test. So I'm erasing this part. That method is perfectly fine, but the method which I use is simple and less time consuming. This is 21.5, the test value is here, this 15 is here, and this is in square root. And the z-test is 1.938. Now compare this value with this critical value. This value lies in critical region, so you have to reject H naught. You have to accept this fact that P has increased, or her claim is justified. Another question of normal approximation to binomial. A 6-sided die shows a 6 on 25 throws out of 200. So this is n of binomial. And this is the test value. 10% significance, 1 upon 6 less than 1 upon 6. Since n is very large, so you have to use normal approximation. Again, you have to do continuity correction. And since your H1, this has lesser sign, so you have to perform the lower tail test, this tail. The test value is always inclusive, so you have to go on this side because of this lesser sign. So the continuity correction will be 25.5. So you have to use this number here. And NP is here and NPQ is here under root. Now you need to compare this value with the critical value. This value lies in critical region. So you have to reject H naught. You have to accept this fact that P has decreased. I'm very tired because the time is 10:32. I usually sleep at around 9:30 or 10. But because of the test of the students, I'm making this lecture. I hope I will not make any mistake. Sami claims that he can read minds. Now this is the claim of Sami. He asks each of 50 people, this is n of binomial, to choose one of the 5 letters A, B, C, D. So 1 must be correct, so 1 upon 5. Since this is 50, very large number, so use normal approximation. He then tells each person which letter he believes they have chosen. He gets 13, this is the test value. Sami says this shows that I can read minds because 13 is more than I would have got right if I were just guessing. So this has greater sign. This is his claim. Null and alternative hypotheses are here. Significance 10%. You have to do continuity correction. This value is always inclusive. So after continuity correction, this will become 12.5. Z-test is 12.5, NP, NPQ. Now you need to compare this number with this number. This is for your conceptual clarity. This number is 1.282, Z critical, 10%. Since this number does not lie in critical regions, so you have to accept H naught. You have to reject the claim. His claim is not justified because this does not lie in critical. Now, this is the last topic of this lecture, normal approximation to Poisson distribution. We do this when lambda of Poisson is greater than 15, and we also do continuity correction. And we use number line for that. At a certain company, computer faults occur randomly at a constant mean rate. This is the Poisson distribution case. 2.1 is lambda per week, and for 20 randomly weeks, that means lambda must be changed. This is 2.1 for 1 week, and for 20 it must be 42. This calculation is here. This is the test value 54. Suitable approximation means normal approximation. 5% mean rate has changed. This is the two-tailed test. So 1.96, 1.96, negative 1.696 is here. You have to do the continuity correction since, now this is very important. Understand this concept carefully. Since this test value, since the test value is greater than the mu, see, this test value is greater than mu, so we have to perform this upper tail test. What if the test value was 36.5? Then we had to perform this test. That is why I'm taking 53.5. This thing is very important. Understand this thing well. When the test value is greater than mu, then perform this upper tail test. Meaning do continuity correction in this way. And when the test value is less than mu, then perform the lower tail test, this test. So Z test is 1.774, Z test lies here. So except H naught, that lambda has not changed. Lambda or mu. Since you are approximating this, so you should write here, you can write even a lambda mu here. You can write this as mu 42. Or you can just write mean has not changed. This would be the safest thing. Instead of writing mu is fine, but lambda is mean and mu is also mean. So you can just write mean. Mean means lambda or mu has not changed. This will be the last question, I guess, of this lecture. Thank God. Narika has a die which is known to be biased so that the probability of throwing a 6 on any throw is 1 upon 100. This is the binomial situation, P. This is the P of binomial. She uses an approximating distribution, that means Poisson distribution, because this question is of binomial to Poisson. And we do this when n is greater than 50 and p is less than 0.1. This means Poisson. No sixes in 450 throws. No sixes means test value x is 0. None. Find the percentage error. Percentage error, the formula of percentage error is this. This is the formula of percentage error. If estimate is greater than exact, then estimate minus exact over estimate into 100%. Just learn this formula. Well, the population is binomial. If you will solve this question through binomial, you will get the exact answer. But when you will approximate this question, when you will solve this question through Poisson, you will get the estimated answer. Poisson is an approximation. Approximation will give you estimate, and the population, the original population is binomial. So binomial will give you exact answer. So this is the way to get exact answer, and this is the way to get the estimate. So you just need to check both the answers, and then you can easily get the percentage error. So none in binomial. This is the way to get none in binomial. It's q power n. And the probability of p is 1 upon 100. So probability of q is 99 upon 100 in 450 throws. So this is the probability of none in through binomial. This is the exact answer. Make sure you write the whole number, the entire answer. Well, this is the estimate. When you use Poisson, you get estimated answer because this is the approximation. So you have to use Poisson in this way. E power minus lambda, and lambda is np. So e power minus np. This is e power minus np because lambda is np. So you'll get this answer. Now you just need to substitute these numbers into this formula, and you can easily get the percentage error. If you want to take the screenshot of this solution, you can. (2.29) up to 3 significant figure. Well, this is an advice from this student, Miss Iman. This advice is for me and for everyone. We should think before we speak. So think before you speak. This advice is from this student, a unique student, one of my best students, the most dedicated student. Alhamdulillah. I hope this lecture will help you all to understand how to solve the questions of testing. Well, Allah Hafiz.